Okay, so now that we've gone through and looked at what our formulas are, or what pictures and percentages we're going to use for this unit, let's look at some potential problems you might be asked. So the first one is a sleep study found that the number of hours each person slept was normally distributed. So that sentence lets us know that our graph would look like this graph up here with the empirical rule. So we can use information from the empirical rule, or we can use z-scores to help us out. The study found that the average person slept 8.2 hours with a standard deviation of 0.7 hours. So part 1 says, what range of hours of sleep are 99.7% closest to the mean? So it wants to know this information. It wants to know, I went a little too far over there, sorry. Just our 3 standard deviations in either direction. So 99.7, about all values fall within 99, within 3 standard deviations from the mean. Okay, so looking at our mean here, our mean is 8.2 hours, and our standard deviation is 0.7 hours. Okay, so if we want to know our range of hours of sleep that 99.7% of the population falls between, then we can take our mean, which is 8.2 hours, and we can add to it to get our maximum amount of hours here 3 times our standard deviation, because our maximum number here is going to be 3 times our standard deviation plus the mean. That's not a 6, that's a sigma or that's not a sigma, but that's like your standard deviation symbol. Okay, so if you go on your calculator, you can just do this really quickly. We have 8.2 plus 3 times 0.7. So 10.3 hours of sleep. Wow, must be nice. While we are all away from school, maybe you are prioritizing your sleep. Maybe you're taking some naps. I don't know. But that would be nice if, with all the hustle and bustle of our regular lives, if we got 10.3 hours of sleep per night. But that is 3 standard deviations above our mean. So that is on the higher end of the amount of sleep that people get per night. Now, to find the lower end, we're going to do a similar process. We're going to do 8.2 minus 3 times 0.7. So again, I'm just going to use my calculator here. Oh, I did something wrong. There are too many dots. Too many decimals. 6.1, wow, not a good night, right? When I only get 6.1 hours of sleep, usually not feeling it. So what range of hours of sleep are the 99.7 closest to the mean? The answer to that is 6.1 hours to 10.3 hours. Sometimes you might see it written as 6.1 minus 10.3. It's not really meant as minus, it's just meant to. Like 6.1 to 10.3. So that is our range of hours. That 99% of the population averages between 6.1 hours of sleep and 10.3 hours of sleep per night. And that should seem pretty reasonable considering all things. Problem number 2, the 2.5% of people who slept the most got more than how many hours of sleep? Okay, so now it's giving us a percentage, but it's not a percentage that we have on this graph. So what I want to show you is that let's look at this 95% one. If 95% of the data, and I'm even going to color in the graph to show you where 95% of the data falls in. So if 95% of the data falls within these points, that means 5% of the data is not within those points. So that means 5% of the data falls in this tail and in this tail. And this is a symmetric graph. So if we have 5% of data distributed evenly between 2 places, 5 divided by 2 is 2.5% of data. So now it might make more sense why this question is saying if 2.5% of the people who slept the most, because we can find that 2.5%, I'm actually going to use a different color. Let's use blue. That 2.5% of people that slept the most, those are these people right over here. Okay? So we're looking at that blue-green part of our graph. The 2.5% of people who slept the most got more than how many hours of sleep? We want to know how many hours of sleep these people got. So in order to determine how many hours of sleep these people got, since they are 2.5% or 2.5% of the people who slept the most, keep in mind that this is that little cutoff, right? So we would love to know this data point. But if you look at the label below, it says it's the mean plus 2 times the standard deviation is where that data point is. So we can use that information. We know our mean, which is 8.2, plus 2 times our standard deviation, which is 0.7. And that's going to give us our data point for this. So we have 8.2 plus 2 times 0.7. So 9.6. So 2.5% of the population, it's not 9.6%. I started writing a percent because I was saying a percent. So 9.6 hours is the amount of sleep that 2.5% of the population gets every night. That would be very nice for those 2.5%. And the last problem with relation to this example is the 16% of the people who slept the least got less than how many hours of sleep. So similar concept, I'm going to erase my work from before on this graph so we can look at it all together. But it says 16%, so I want you to focus on this 68%. So if we have 100 minus 68%, that's not as easy of math to do in your head, but 100 minus 68 is 32. So if 68% of your data is in this yellow shaded area of our graph, then that means, let me erase this also, then that means 32% of our data falls on these edges. But this is a symmetric graph, so that means there's the same percentage of data on both sides of this curve. So that means there is 16% of data, and it cares about the people that slept the least amount this time. So this blue-green area is that 16% of the population that we are talking about. So the 16% of the people who slept the least got how many hours of sleep? Well, let's look at our cutoff point here. Our cutoff point is right here. That is 1 standard deviation away from our mean. So in order to mathematically determine that, we're going to take our mean and we're going to subtract, because we are below the mean, just 1 standard deviation. So 1 times 0.7, or just 8.2 minus 0.7. So that is just going to give us 7.5 hours. So 16% of people get less than 7.5 hours of sleep is our answer to part 3. So hopefully what I did on this problem makes sense. You will have a significant amount of problems that are similar to this because they all deal with logic and reasoning in terms of figuring out what area of this graph you are looking at, and then it's pretty basic math once you determine what area of the graph you're looking at.